You know what's wild? Most people spend more time planning their Netflix queue than they do planning their lawn care automation. And then they wonder why their smart sprinkler system waters the lawn during a rainstorm, or their robotic mower gets stuck in the same corner every single time. My name is Marcus Chin, and I've spent the last 8 years installing smart lawn care systems across the Pacific Northwest. And I can tell you right now, the biggest failures don't come from buying the wrong equipment. They come from not understanding how these systems actually talk to each other.
You're listening to Smart Home Setup Podcast. Quick note before we jump in. The research, the data, all the script work here is written and verified by actual humans with real-world experience, but the voice you're hearing right now is AI-generated. Just wanted to be upfront about that. If you've been listening for a while, thank you. Seriously, it's good to have you back. And if you're new here, welcome to the show. New episodes drop every Monday, Wednesday, and Friday, so plenty to catch up on if you want to dive deeper into smart home gear that actually works. Now, here's what we've got for you today. So let's talk about what actually works when you're automating your lawn care with smart home integration. This isn't just about convenience. It's about building a reliable system that maintains your yard with minimal intervention. You're going to get actionable steps for connecting robotic mowers, smart irrigation controllers, and outdoor sensors to your existing smart home ecosystem, complete with protocol requirements and automation logic you can implement today. In my experience, homeowners who succeed with lawn care automation start by understanding compatibility planning before buying a single device. The biggest mistakes happen when someone purchases a robotic mower that can't communicate with their hub, or sets up irrigation zones without understanding the actual automation triggers needed for weather-responsive watering. Now, let's talk about smart irrigation controllers with weather integration. The Rachio 3 Smart Sprinkler Controller, check the link below to see the current price, connects via Wi-Fi and integrates with your smart home through cloud-to-cloud APIs, meaning it doesn't use Zigbee, Z-Wave, or Thread. You'll get weather-responsive watering schedules that automatically adjust based on forecast data, soil moisture calculations, and seasonal changes. This category belongs on the list because irrigation represents the highest water consumption in most residential landscapes. Automating it properly can reduce water usage by 30 to 50% while maintaining healthier turf. The automation logic here is more sophisticated than simple timers. It uses Wi-Fi, specifically 2.4 gigahertz, which is required. For hub requirements, it works standalone via mobile app, but requires integration through SmartThings, Home Assistant, Google Home, or Alexa for cross-device automation. Here's your compatibility checklist in practical terms. Verify your router supports 2.4 gigahertz Wi-Fi because 5 gigahertz won't work. Check wire count from your existing controller since most support 8 to 16 zones. And confirm you have a C wire for 24-volt power. Also, test Wi-Fi signal strength at the controller location before installation. Don't assume it's strong enough. For automation logic, think about it this way. If the weather forecast shows precipitation probability over 60% and the amount is more than a quarter inch, skip the next watering cycle. If soil moisture estimate drops below the threshold for your grass type and it's the scheduled zone time and outdoor temperature is above 40 degrees Fahrenheit, run the zone for the calculated duration. I've seen homeowners struggle with the initial zone configuration. You need to accurately input your sprinkler head types, spray versus rotor, sun exposure per zone, and soil type for the weather algorithms to work correctly. Garbage in, garbage out.
For latency expectations, this is cloud-dependent with 2 to 5 second response times for manual commands. Weather data updates hourly. The system operates autonomously for scheduled runs, so latency only affects on-demand manual control. If your internet connection drops, the controller maintains the last programmed schedule but loses weather intelligence. You can manually operate zones via physical buttons on most models. One genuine drawback, cloud dependency, means if Rachio's servers go down, rare but it happens, you lose app control and weather integration until service restores. This is why understanding fallback behaviors matters for outdoor systems. Moving on to robotic lawnmowers with GPS boundary mapping. The Husqvarna Automower 450XH, check the link below, uses proprietary RF for boundary wire communication and cellular or Wi-Fi for smart home connectivity. This is the flagship approach to automating lawn care for cutting tasks. Set boundaries once, then let the mower handle scheduling based on grass growth rates and weather conditions. Robotic mowers belong on this list because they eliminate the most time-consuming lawn maintenance task while providing more consistent cutting than weekly manual mowing. The automation potential extends beyond simple scheduling when you integrate with weather sensors and moisture detection. It uses Husqvarna's proprietary communication plus Wi-Fi or cellular for cloud connectivity. For hub requirements, you need a Husqvarna Fleet Services account. Integration with Home Assistant, IFTTT, or Amazon Alexa requires third-party plugins or cloud-to-cloud connections. No native Zigbee or Z-Wave support. Installation requirements are straightforward but time-consuming. Bury or stake boundary wire around your mowing area perimeter, install the charging station on level ground with 2 meters clearance, provide an outdoor power outlet that's GFCI protected within 10 feet of the charging base, and map GPS coordinates for theft tracking and remote monitoring. For automation logic, if grass growth rate is high during spring season, set mowing frequency to daily. If the soil moisture sensor shows conditions are too wet or weather forecast shows active precipitation, pause mowing until conditions dry. If the current time is in quiet hours, say 10 p.m. to 7 a.m., and mowing is incomplete, pause and resume at 7 a.m. Commands from app to mower typically take 3 to 8 seconds over cellular, 2 to 4 seconds over Wi-Fi. The mower operates autonomously once scheduled, so latency only affects manual interventions like return to base commands. Boundary wire breaks are the most common failure point. I've seen landscape edging, tree roots, and curious dogs all cause wire damage. The mower won't leave the charging station if it can't detect the boundary signal. GPS tracking works well, but thick tree canopy can degrade position accuracy by 1 to 3 meters. If connectivity drops, the mower continues its current task and follows the existing schedule. You lose remote monitoring and manual control until connection restores. Physical stop button always works regardless of connectivity. The biggest drawback here is the initial setup complexity. Boundary wire installation typically takes 4 to 8 hours for a half-acre lot if you're doing it yourself. The wire needs to be precisely placed around obstacles, flower beds, and steep slopes. You can hire professional installation, but expect to add around $400 to $800 to your total cost. Now let's talk about outdoor smart plugs for lighting and pump automation. The Casa Smart Outdoor Plug EP40, check the link below, uses Wi-Fi and provides weatherproof control for landscape lighting, fountain pumps, or secondary irrigation pumps. You can create time-based or sensor-triggered automations that coordinate outdoor power devices with your broader lawn care schedule. Smart outdoor plugs earn a spot because they bridge the gap between non-smart lawn equipment and your automation ecosystem. Suddenly, that standard fountain pump or LED landscape lighting becomes part of your coordinated yard automation without replacing the actual devices. It uses Wi-Fi 2.4 gigahertz only. For hub requirements, you don't need a hub for basic scheduling via the Casa app. For integration with Google Home, Alexa, or SmartThings, you'll need the respective platform hub or smart speaker. Here's what to check. Verify Wi-Fi strength at the outlet location because outdoor walls often have poor signal. Check IP rating, IP64 minimum for covered areas, IP65 or higher for exposed locations. Confirm the outlet is GFCI protected per electrical code, and test load requirements. Most support 15 amps per outlet, but verify your device draw. For automation logic, think about triggering landscape lighting to power on 30 minutes before sunset, power off 30 minutes after sunrise. If soil moisture drops below critical threshold and the primary irrigation system is offline, turn on the backup pump for 20 minutes. If outdoor temperature drops below 35 degrees Fahrenheit, turn off all outdoor water features. Wi-Fi smart plugs typically respond in 1 to 3 seconds for local commands on the same network, 2 to 5 seconds for cloud-based commands when you're away from home. Scheduled automations execute with sub-second precision.
In my experience, outdoor Wi-Fi range is the make or break factor. I've seen installations fail because the homeowner assumed their router signal reached the far corner of the yard. It didn't. Always test signal strength before mounting permanent fixtures. Consider a Wi-Fi extender for distant outlet locations. Weather sealing degrades over time. Check gaskets annually and ensure covers are fully closed after plugging devices in. Water infiltration is the primary failure mode.
If Wi-Fi drops, the plug maintains its current state, on or off, until connectivity returns. Scheduled automations won't execute during outages. No local control option unless the plug has physical buttons, and some models do, others don't. The honest drawback, Wi-Fi outdoor plugs draw phantom power even when the connected device is off, usually 1 to 3 watts. Over dozens of devices and months of operation, this adds up. Moving on to soil moisture sensors with Zigbee or Wi-Fi connectivity. The EchoWit soil moisture sensor, check the link below, connects via Wi-Fi through the EchoWit gateway and provides real-time moisture readings for up to 8 sensor probes. These sensors transform how you automate lawn care watering decisions from time-based guessing to data-driven precision. Soil moisture sensing deserves inclusion because it's the single most impactful data point for irrigation automation. It's more valuable than weather forecasts because it tells you what's actually happening at root level rather than what might happen based on regional weather predictions. It uses 915 MHz proprietary wireless to the EchoWit gateway, then Wi-Fi from gateway to network. For hub requirements, you need an EchoWit Wi-Fi gateway. That's a separate purchase. Integration with Home Assistant, WeatherFlow, or IFTTT requires cloud API connections. Installation requirements. Insert probes 4 to 6 inches deep in representative zones, not too close to sprinkler heads. Position the gateway within 100 feet of sensors with clear line of sight when possible. Power the gateway via USB or outlet within Wi-Fi range. Calibrate sensors for your specific soil type, clay, loam, or sand. For automation logic, if Zone 1 moisture drops below 25% and it's 6 a.m. and there's no rain forecast for the next 6 hours, trigger Zone 1 irrigation for a duration calculated to reach 45% moisture. If Zone 1 moisture is above 60%, cancel the scheduled irrigation for that zone. If any zone moisture drops below 15%, that's critically dry, send an alert notification and trigger emergency irrigation. Sensors report readings every 16 to 60 seconds, depending on configuration. Gateway to cloud updates occur every 30 to 60 seconds. For irrigation decisions, this latency is acceptable, since soil moisture changes slowly. Probe corrosion is the long-term concern. Expect a 2 to 3 year lifespan in typical soil conditions, shorter in acidic or high mineral soils. Battery life varies by reporting frequency, typically 12 to 18 months on included batteries. I've seen homeowners place sensors poorly, too close to the house foundation, which doesn't represent the lawn, too shallow, which reads surface moisture that evaporates quickly, or in one spot for a large zone with variable sun exposure. You need representative placement for accurate automation decisions. If the gateway loses Wi-Fi, local sensor-to-gateway communication continues, but you lose remote monitoring and integration triggers. Most irrigation controllers will fall back to scheduled watering rather than maintaining soil-based intelligence. The specific drawback here, calibration is tedious but essential. Out-of-box readings are often 10 to 15% off for specific soil types. You'll need to manually water to saturation, record the wet reading, let the area dry for a week, record the dry reading, then input these values for accurate thresholds.
Now let's talk about weather stations with hyperlocal data integration. The Ambient Weather WS2902C Osprey, check the link below, provides Wi-Fi connected hyperlocal weather data including rainfall, temperature, humidity, wind speed, and UV index. This data feeds directly into your lawn care automation decisions, replacing regional forecasts with what's actually happening in your yard. Weather stations make the list because regional forecasts can be off by 20 to 30% for rainfall amounts and several degrees for temperature. Those differences matter when you're trying to optimize watering schedules and protect sensitive plantings from frost. It uses Wi-Fi, 2.4 gigahertz, with optional integration to Weather Underground, Ambient Weather Network, and smart home platforms. For hub requirements, none for standalone operation. Integration with Home Assistant, SmartThings, or irrigation controllers requires API connections through Weather Underground or Ambient Weather Cloud services. Installation requirements: mount the sensor array at least 5 feet above ground, 30 feet from structures for accurate wind readings. Position the rain gauge away from roof drip lines and tree canopy. Level the base carefully because unlevel mounting affects rain measurement. Mount the console indoors within Wi-Fi range of your router. Position the temperature sensor in a shaded location for accurate readings. For automation logic, if local rainfall today is more than ½ an inch, skip all irrigation today. If local temperature drops below 38 degrees Fahrenheit and frost forecast is true, trigger frost protection irrigation. That's a light sprinkle to warm plants. If wind speed exceeds 15 miles per hour, delay lawn treatment spray schedules. If UV index is above 8 and outdoor work is scheduled, send a heat advisory notification. The console updates readings every 16 to 64 seconds depending on the sensor. Cloud uploads occur every 30 to 60 seconds. Weather Underground typically updates your personal station data within 2 to 3 minutes. Wind cups and rain gauge mechanisms require annual cleaning. Spider webs, leaves, and bird nests all cause false readings. Temperature sensor accuracy degrades if exposed to direct sunlight. Expect to recalibrate annually using a reference thermometer.
In my experience, the most common mistake is mounting the sensor array too close to the house or under eaves. This creates a microclimate that doesn't represent your actual yard conditions. You want representative placement, which often means running 50+ feet of cable or using a separate Wi-Fi bridge. If Wi-Fi drops, the console continues displaying current readings but stops uploading to cloud services and integration platforms. Smart home automations that depend on weather data will fail or fall back to predetermined schedules. The real drawback: birds. Seriously, birds love perching on weather station components, and their droppings foul sensors. The rain gauge is particularly vulnerable. You'll need to clean it monthly during heavy bird migration seasons, or expect rainfall measurements to read 20 to 30% low. Moving on to smart outdoor security cameras with lawn monitoring, the Reolink RLC810A, check the link below, uses Wi-Fi or PoE, which is Power over Ethernet, and provides 4K video monitoring of your yard with person and vehicle AI detection. While primarily a security device, you can leverage motion detection zones to monitor lawn care equipment activity and verify automation task completion. Outdoor cameras earn their place because they provide visual verification that automated systems are functioning correctly. You can check whether the robotic mower actually completed its cycle, confirm irrigation zones activated, or diagnose why the system behaved unexpectedly. It uses Wi-Fi, both 2.4 and 5 gigahertz, or wired PoE Ethernet. For hub requirements, none for standalone operation with local microSD or NAS recording. For smart home integration with Home Assistant, SmartThings, or surveillance systems, you'll need ONVIF or RTSP stream support. Installation requirements: position the camera to cover your mower charging station, irrigation controller area, or problem zones. Provide a PoE injector or switch or a nearby power outlet. Mount at 8 to 10 feet height for optimal field of view. Angle slightly downward to minimize sky exposure, which prevents auto exposure issues. Ensure a Wi-Fi signal strength at -65 dBm or better for reliable 4K streaming. For automation logic, if camera zone 1 detects a person and the current time is in the mowing schedule, pause the robotic mower and send a notification. If camera zone 2 shows no motion detected and irrigation zone 2's scheduled run is complete, send an alert saying irrigation may have failed because no water spray was detected. If the camera temperature drops below 32 degrees Fahrenheit and outdoor water lines are exposed, send a freeze warning. Local stream viewing has 200 to 500 milliseconds latency. Cloud-based viewing adds 1 to 3 seconds. AI person and vehicle detection typically processes within 1 to 2 seconds. For yard monitoring, this latency is acceptable.
Cameras exposed to direct sunlight suffer from auto exposure challenges. Bright sky backgrounds cause dark foreground subjects. IR night vision attracts insects, which trigger false motion alerts. Lens condensation in high humidity climates requires periodic cleaning. I've seen installations fail because homeowners underestimate Wi-Fi bandwidth requirements. A single 4K camera streaming continuously can consume 8 to 12 megabits per second upload bandwidth. Multiple cameras quickly saturate typical residential internet upload speeds. PoE eliminates bandwidth concerns by using wired connection. With local storage, micro SD or NAS, recording continues during internet outages, but you lose remote viewing and notifications. Without local storage, you lose all recording during connectivity loss. The honest limitation: outdoor cameras with AI detection often produce false positives from swaying tree branches, moving shadows, or animals. Expect to spend time fine-tuning motion zones and sensitivity levels. The first week will generate dozens of alerts until you dial in the settings correctly. Now let's talk about smart outdoor lighting with dusk-to-dawn automation. The Philips Hue outdoor light strip, check the link below, uses Zigbee through the Hue bridge and provides weatherproof RGB lighting for landscape features, pathways, or architectural accents. Coordinating outdoor lighting with lawn care schedules creates a holistic yard automation system. Smart outdoor lighting belongs here because proper illumination extends your ability to monitor automated equipment, highlights landscaping improvements from your care routine, and provides safety lighting for early morning or evening yard work. It uses Zigbee 3.0. For hub requirements, you need a Philips Hue bridge, which uses Ethernet connection to your router. The bridge supports up to 50 Hue lights and integrates with Google Home, Alexa, HomeKit, and Home Assistant. Here's your compatibility checklist. Verify the Hue bridge is within Zigbee mesh range, typically 30 to 50 feet outdoors. Check if you need additional outdoor Hue lights as Zigbee repeaters for distant installations. Confirm GFCI protected outdoor outlet within 6 feet of light strip installation point. Plan cable routing to avoid mower paths and foot traffic areas. For automation logic, turn landscape lights on at 15 minutes before sunset, 100% brightness, 2700 Kelvin color temperature. If the robotic mower status is active and current time is after sunset, set pathway lights to 100% brightness for visibility. If security camera detects a person and current time is in night hours, set accent lights to cool white, 100% brightness, flash twice. Turn all landscape lights off 30 minutes after sunrise.
Zigbee commands typically execute in 100 to 300 milliseconds for color and brightness changes. Scheduled automations trigger within 1 to 2 seconds of target time. The mesh network provides reliable, low-latency performance. Zigbee mesh networks depend on powered devices as repeaters. If you have only a few outdoor lights far from the bridge, connectivity may be unstable. Each additional powered Zigbee device strengthens the mesh. Temperature extremes don't significantly affect Zigbee performance, but metal siding and stucco walls can block signals. In my experience, homeowners underestimate how many Zigbee repeaters they need for outdoor coverage. Interior devices don't effectively extend the mesh through exterior walls. Plan on at least one outdoor-powered Zigbee device, plug or light, every 30 to 40 feet for reliable coverage. If the Hue bridge loses internet, local automations created through the Hue app continue working, time-based schedules and sensors. Cloud-based integrations through Google, Alexa, or HomeKit stop working until internet returns. Physical power switch always controls lights. The specific drawback: outdoor light strips are significantly more expensive per foot than indoor versions, typically 2 to 3 times the cost for the same length due to weatherproof construction. The mounting clips are also somewhat flimsy for the weight of the weatherproof strip, especially when installing on vertical surfaces. Moving on to smart hose timers for supplemental watering. The Orbit Beehive Smart Hose Faucet Timer, check the link below, uses Wi-Fi and provides scheduled or on-demand control for hose-connected drip irrigation, soaker hoses, or hand watering routines. These complement in-ground irrigation systems by handling garden beds, containers, or areas not covered by permanent sprinklers. Hose timers make the list because they're the easiest entry point for automating smart home watering. No installation complexity, no wiring, just thread it onto an existing hose bib and configure via app. It uses Wi-Fi, 2.4 gigahertz, with optional Bluetooth for local connection. For hub requirements, none for standalone use. Integration with Alexa or Google Home requires cloud-to-cloud connection through Beehive Cloud Service. Installation requirements: thread onto standard 3/4-inch hose bib, attach hose or drip irrigation system to timer outlet, install 4 AA batteries, which typically last 12 months, connect to Wi-Fi via app during initial setup, and test for leaks at connections. Add a hose washer if needed. For automation logic, if container plant's zone soil moisture drops below 30% and current time is 7 a.m., run the drip system timer for 30 minutes. If weather forecast high temperature exceeds 95 degrees Fahrenheit, increase drip duration to 45 minutes. If rain gauge shows yesterday's rainfall exceeded a 1/4 inch, skip drip watering today.
Wi-Fi commands execute in 2 to 5 seconds. Scheduled automations trigger within 1 to 2 seconds of target time. Bluetooth local control, when you're in range, responds in under 1 second. Battery life decreases in cold weather. Expect 6 to 8 months instead of 12 in climates with freezing winters. Low voltage warning typically provides 2 to 3 weeks notice before complete battery failure. Water pressure fluctuations can affect watering consistency. I've seen frequent failures from incorrect battery installation and corrosion. The battery compartment isn't fully sealed and morning dew condensation can accumulate. Apply dielectric grease to contacts annually to prevent corrosion issues. If Wi-Fi drops, the timer maintains its current schedule and will execute programmed runs. You lose remote monitoring and manual override capability until connection returns. Physical manual on button works regardless of connectivity. The practical limitation: water pressure at hose bibs is often lower than inline irrigation pressure, affecting sprinkler performance if you're using this for spray irrigation rather than drip systems. Flow rates are typically 5 to 8 gallons per minute versus 12 to 20 gallons per minute for in-ground systems. Also, the timer adds about 4 inches of length to the hose bib, which can create awkward positioning in tight spaces. Now let's talk about smart garden sensors with NPK and pH monitoring. The Sensor Push HT1 temperature and humidity sensor, check the link below, provides Bluetooth monitoring with optional Wi-Fi gateway for extended range. While this specific model focuses on temperature and humidity, similar sensors exist for soil NPK, that's nitrogen, phosphorus, potassium, and pH that inform fertilization automation decisions. Multi-parameter garden sensors deserve inclusion because they transform fertilization from calendar-based guessing to condition-responsive precision. You can automate alerts when pH drifts out of range or NPK levels indicate deficiencies, preventing both waste and lawn damage from over-application. It uses Bluetooth 5.0 with optional Wi-Fi gateway, the G1 Wi-Fi gateway, for extended range and cloud integration. For hub requirements, none for local Bluetooth monitoring via smartphone within 100-foot range. The G1 gateway is required for remote access and integration with Home Assistant, IFTTT, or custom automations. Installation requirements: place sensors in representative zones, sun and shade, wet and dry areas. Insert soil probes to consistent 4-inch depth. Position the gateway within 325-foot Bluetooth range of sensors. Calibrate according to manufacturer instructions with known reference solutions.
For automation logic, if soil pH drops below 6.0, too acidic for grass, send an alert to apply lime treatment to Zone 2. If soil nitrogen is below optimal for season and last fertilization was more than 45 days ago, send a reminder to schedule nitrogen application. If soil temperature drops below 50 degrees Fahrenheit, cancel the seeding scheduled activity because grass won't germinate. Bluetooth sensors update readings every 1 to 5 minutes. Gateway uploads to cloud every 5 to 15 minutes. For soil chemistry, which changes slowly, these update intervals are appropriate. Soil probes require periodic cleaning and recalibration. Organic matter buildup and mineral deposits affect accuracy over time. Budget sensors often drift significantly after 6 to 12 months. Professional-grade sensors, $200 and up, maintain accuracy longer but require annual calibration. In my experience, homeowners get frustrated with NPK sensors because they expect precision comparable to lab testing. You won't get it. Budget sensors provide directional accuracy, high, medium, low, rather than precise numerical values. Use them to identify trends and gross deficiencies, not to fine-tune fertilizer recipes. Sensors continue collecting data locally in Bluetooth range even without gateway or internet. Data uploads to the cloud once connectivity restores. Most maintain 30 to 45 days of local storage. The genuine drawback: sensor accuracy varies wildly by manufacturer and price point. Many budget sensors read pH within plus or minus 0.5 units, which is barely useful since optimal grass pH is 6.0 to 7.0. That plus or minus 0.5 uncertainty covers half the acceptable range. If you need true precision, invest in professional-grade sensors or periodic lab soil testing. And finally, voice control integration for manual overrides. Amazon Echo or Google Nest outdoor-rated speakers provide Wi-Fi voice control access points in yard areas, enabling hands-free manual overrides of automated systems while you're actively working outdoors. It uses Wi-Fi, both 2.4 and 5 gigahertz dual band. For hub requirements, it acts as its own hub for Alexa or Google ecosystems. Integrates with Zigbee devices on Echo models with built-in hub. Z-Wave via SmartThings integration, Thread on newer Echo models, and Matter devices.
Installation requirements: place speaker under covered area like a patio or gazebo, or use an outdoor rated model. Ensure Wi-Fi signal strength at -60 dBm or better. Power via nearby GFCI outlet. Configure voice profiles for household members in the app. Create custom routines for common lawn care commands. For automation logic, think about voice commands like Alexa, pause lawn maintenance, which would trigger the robotic mower to pause,
all irrigation zones to pause, and yard motion sensors to disable for 30 minutes. Or, hey Google, emergency lawn watering, which would run all irrigation zones sequentially for 10 minutes each and send a notification that manual emergency watering started. Voice recognition to command execution typically takes 1 to 3 seconds. Local device control, same network Zigbee or Thread devices, adds 200 to 500 milliseconds. Cloud-dependent devices add 1 to 2 seconds. Outdoor ambient noise, wind, traffic, lawn equipment significantly affects voice recognition accuracy. I've seen recognition rates drop from 95% indoors to 60 to 70% outdoors on windy days. Background noise from running mowers or sprinklers prevents reliable voice control. In my experience, outdoor voice control works best for pre-work setup commands, like Alexa, prepare the yard for mowing, rather than real-time control while equipment is running. Create routines that pause multiple systems with single voice commands, rather than trying to control devices individually mid-task. If internet drops, cloud-based voice commands fail completely. You can't control Wi-Fi irrigation controllers or cloud-connected mowers. Local Zigbee or Thread device control may continue working on newer Echo models with local processing, but functionality is limited. The specific drawback? Outdoor speakers degrade faster than indoor units despite weather-resistant ratings. UV exposure fades surfaces, temperature cycling loosens adhesives, and moisture eventually infiltrates. Budget for replacement every 2 to 3 years for uncovered installations versus 5+ years indoors. So how did I make these picks? I selected these devices based on 8+ years installing smart lawn care systems across Pacific Northwest residential properties, focusing on plug-and-play reliability rather than specification sheet impressions. Every product here passed 3 criteria: protocol compatibility with mainstream hubs, no proprietary dead ends, demonstrated reliability through at least 1 full growing season in client installations, and genuine automation potential beyond simple scheduling.
The irrigation controllers and weather stations made the list because they form the foundation of lawn care automation. You can't optimize watering without knowing what's happening at ground level and in your specific microclimate. Robotic mowers and smart plugs bridge the gap between traditional lawn equipment and modern automation. Sensors and cameras provide the verification loop that ensures automated systems are actually performing as intended. I prioritize devices that work when internet fails or hubs restart. Scheduled irrigation must continue during network outages, and physical overrides must always function. I excluded products requiring monthly subscriptions for core functionality, looking at you, John Deere, because lawn care automation should reduce ongoing costs, not create new ones. In my experience, successful lawn automation depends more on understanding automation logic and system integration than buying expensive flagship products. A $200 smart irrigation controller with proper soil sensors and weather integration outperforms a $500 controller operating on fixed schedules. The devices on this list work together, not just individually, which is how you build resilient yard automation. Let me answer some frequently asked questions. What smart home protocol is best for lawn care automation? Wi-Fi dominates lawn care automation because irrigation controllers, weather stations, and robotic mowers require internet connectivity for weather API integration and remote monitoring. However, Zigbee excels for sensors and outdoor lighting due to superior mesh networking and lower power consumption. Use Wi-Fi for high-bandwidth devices like cameras and controllers, and Zigbee for battery-powered sensors. You'll often run both protocols simultaneously in a complete yard automation system. Can I automate lawn care without a smart home hub? Yes, most irrigation controllers and robotic mowers operate standalone through manufacturer apps without requiring a central hub, but you lose cross-device automation capabilities that make lawn care truly intelligent.
For example, coordinating irrigation pauses when the robotic mower is active requires hub-level automation logic. Start with standalone Wi-Fi devices for basic automation, then add a hub, SmartThings, or Home Assistant later when you want conditional logic like skip watering if soil moisture is high and forecast shows rain.
How reliable is smart lawn care automation during internet outages? Devices with local scheduling maintain core functions during outages. Irrigation controllers run their programmed schedules, robotic mowers continue existing routes, and smart plugs maintain their on-off state. You lose remote monitoring, weather integration, and complex conditional automations until internet returns. This is why hybrid automation approaches work best. Use weather-intelligent scheduling during normal operation, but ensure devices fall back to sensible, time-based defaults during connectivity loss. What's the typical setup time for complete lawn care automation? Plan 8 to 15 hours for full installation across a typical quarter-acre property, 4 to 6 hours for robotic mower boundary wire installation, 2 to 3 hours for irrigation controller installation and zone configuration, 1 to 2 hours for weather station mounting and calibration, plus 1 to 2 hours for sensor placement and integration setup. Stagger installation over 2 to 3 weekends to avoid overwhelm. Start with irrigation since it has the highest impact. Add the mower next for the highest time savings, then layer in sensors and cameras for optimization. Here are my final thoughts. Automating your lawn care through smart home integration delivers measurable time savings. I've seen clients reclaim 4 to 6 hours weekly by eliminating manual mowing and irrigation adjustments. But success depends on understanding how these systems interact, rather than simply accumulating connected devices. Start with weather-responsive irrigation since it provides immediate water cost savings and healthier turf, then add robotic mowing for time recovery, and finally layer in sensors for optimization. The most reliable lawn care automation systems use multiple protocols working together. Wi-Fi for internet-dependent controllers and cameras, Zigbee for battery-powered sensors and outdoor lighting, and manufacturer proprietary systems for robotic mowers. Focus on devices with documented API integrations or native hub support, rather than promised future compatibility. According to the National Association of Landscape Professionals, properly automated irrigation reduces residential water consumption by 30 to 50% while improving lawn health through consistent, data-driven watering. That's not just cost savings, it's environmental stewardship through better technology application.